This is Mike V from Reliable Automotive Equipment, and today we're going to be talking about the Express 800 rivet gun assembly, the different functions of it, the different heads on it, and the basics of the system itself. This is the actual main module that is going to power everything. This is your switch for activating it to go on. These controls in the back, this will control the speed of it coming out by adjusting it in or out, and this will control the power setting. That way, as you go to set a rivet, you can maintain a speed that you want and still maintain power regardless of the air pressure coming in. This part in the front is the on-off switch for the hydraulic fluid. When this is forward, this is open. This is the way we're going to use it when we mount the head assemblies on it. Flip it back and that will close the system off so that the system will function correctly. This is a piece that as you push it out, you're able to hold it in the out position for as long as you need to till you're finished with the operation. The mounting of all the head assemblies will go on here. This coupler has a little piece that swings out. This piece rotates back about 1/4 of an inch, and that allows everything inside to accept the head assembly. This is the basic head assembly as we go into self-piercing rivets. So this assembly will go in with the hydraulics, get it flush, turn the collar back, and set the pin down. So the head can rotate on it, and it's loaded on the system. The arm assemblies, 3 different size arms. This is the smallest of them. They all have a locking pin in the back here that as you go through and rotate this, this will line up with this groove in the head assembly. So when this piece goes on, there is a little roll pin that sticks out right here on the inside. This little groove in here, that roll pin will go into there and line up so that the locking pin will be lined up with the groove in the back. So as we rotate that on, the roll pin drops in. When you can put this all the way back, this is locked onto the head assembly now. So as we start the riveting process, the different die assemblies that come in the kit for the self-piercing dies. So the 2 types of self-piercing rivets are basically a 3mm diameter on the outside and a 5mm diameter. And the basics of a self-piercing rivet is, as its name implies, it does not need a hole. This will actually pierce the metal as it goes through. And once it pierces the metal, the piece that it's actually going to pierce it out on the other side is going to be shoved back inside here, and it actually spreads the outer part of the rivet out. So the way that we put the dies in here, all these dies are marked with letters and numbers. For example, this is E1 and E2. You match the letter to letter so that any E die, this is for the 5mm self-piercing. If we look at the smaller one, this is actually marked as a D2. So if you keep your letters together on the die assemblies, that's what keeps you with a matched set. On all of the self-piercing ones, you will see one with a little magnet in it, and that actually is going to hold the rivet in place when you set it. The other part will be the receiver head on it that will actually end up crushing the piece over on the back side. So when we go to mount these in the gun assembly, we are going to add an adapter to it because these are such small head assemblies that the distance that is in between here will need to be filled up with a spacer. So this generally goes into the piston assembly, and this piece basically goes in, screws into place. Very important on these to make these hand tight. Do not put a wrench on them to tighten them. Once they are snug, they are good. The important part about the rivet dies is that all the stress is meant to be taken on this base piece right here, not on the threads. So if this piece is not locked into the other piece and sitting flat on it, all the stress will be on the thread assembly and it will break. These are made out of ultra high strength steel. They have great compaction ability of compressing, but they have very little strength on pulling back or moving side to side. So it is important to keep the die assemblies snug at all times when they go in. On the receiver part of where the rivet is going to go, this does not matter if it will go on this side or this side. You are going to determine what is best for you for holding the gun on how you want to set the rivets in. On this particular one, we're going to set it in on this side. And this will also screw into the adapter assembly that just went in there. So when we get this snug, I want the base of this head flush with this one. This little space on this outer piece is okay on it because that will compress down when it sets the rivet, and that will become flat, but this one here is most important to have flat when you set that in place. Put the corresponding die assembly on the other side. There's a little piece inside of here, this little black piece here that this will thread into. This should start off relatively easy. If it jams up a little bit, just back off on it, push it around till it gets started, and it will tighten up nice and freely. So once that is snug, we're actually set to set rivets. So on setting self-piercing rivets, there is a chart that comes in your box that tells you what the setting number should be for pressure on the rivets. Obviously, smaller rivets will take less pressure than the bigger rivets. So on these rivets, on the 5mm rivets, they should be a setting of about 3.5. And the way that that is set up is that these little lines, the full lines represent 1. The half line represents a half. So if we go up from the bottom, we would go and turn this to we have 3.5 lines showing. And that's our pressure setting. So when we connect air, make sure that this valve is back, otherwise this will just pump and nothing will come out of it. So speed control on the back, you can hear the different settings on it, so you can control how fast the speed is going to come out. So when this comes out, if you hold this down, that will hold that out and not release it until you let it go. So those are the functions of the handle assembly itself. When you are setting up for riveting, make sure that you follow the repair procedure sheet for the car that you're working on. The rivet that you pick out for the amount of material that you're going through is very specific to the size of the rivet. If you get a rivet that's too small, it's not going to set correctly. If you get a rivet that's too long, there's not going to be enough of it sticking out to be able to form it over. So in your repair procedure sheets, it will tell you what specific rivet goes where, and always go with that. So the way that to slide the rivets in, if you just take the base part of the rivet, set it on top of the die, and just push it over so that it sets into the center of it, the rivet is set correctly. You want to make sure that it's not sitting at a little bit of an angle, because if it does that, then it's just going to not crush correctly and you're going to ruin the setup. So when this goes in, we just take our panel, we're going to let the gun stall out. I still have my finger on the trigger. If you do notice, this little space in here is now completely flush. That is the piece that's supported by a little O-ring, so it can hold the rivet in place, and once it sets it, it will flatten out so that when we set this back, that the rivet is set correctly in the material, it's flush with the surface, and that is what the other side looks like. So this is actually the material that it punched out, which is now pushing it back into the rivet assembly and spreading out the back part of the rivet. So at this point, that's how you set a self-piercing rivet. It's the same identical thing for doing the small ones, and what determines a small or a big one is your repair procedure sheet. Very important to follow those. All right, what we're going to do now, we're going to go into extraction. We're going to change out this head assembly here. So just the opposite of taking off the C-arm, we're going to push in on this button, flip this all the way around. That will release that pin. That comes off. Take the head assembly off. Again, flip the lever up. Make sure that you hold the gun assembly and the head assembly, because when they separate, you could drop one of them. So securely hold, lift up the lever, pull the ring back, head assembly comes off. We're going to be putting on what's now called a push-pull. Same basic push as this piece coming out. What they've added on to it is a pull assembly that actually has air power that now actually retracts the piston coming back. So when we go to extraction and punching holes, it gives it much better control and power. So same assembly on putting together. Piece goes in, push it flat, turn the ring, flip it down, lever back, you're ready to go. On this, we are going to connect the air line. This is a quick connect into this fitting, and it locks it in. To release it, just push that little blue washer in as you pull back on the black hose, and it slides right back out again. So this will activate air into this. Without this being hooked up, this will not return. So this must be hooked up correctly. So now to put the C-arm on here, there is a little ring on the outside part here that screws off. And this ring we will be using later, but for right now it is blocking the little keyway that this roll pin is going to go into. So we're going to take this off, put that aside, put the little C-arm on top. Now when you first put these on, these are a very well machine fit, so in the beginning they might seem a little bit awkward. Once it gets on, rotate around till that pin drops down, flush, put the lever back, we're locked into place. Little maintenance here, make sure that the little red caps keep covered on the back, because this little bit of residual hydraulic fluid will attract dust, and dust getting into the system will end up messing up the inside part of the gun because it's a very small intricate passageway. So cleanliness on this is important. So when we go to set this up, we're going to be using these pieces for extraction of the self-piercing rivets. This piece is going to be the piece that's going to be pushing on the back side of the rivet that just got crushed over. And then this piece on the front will be oversized hole so that the rivet assembly can get pushed out of it. On these, you can put this on either side. Doesn't matter which way that they go, you want to put these on so it's easier for you using the gun. Whatever makes it easy for getting the gun into the assembly, either by putting it up here or this way. Little O-rings on here. These are put in there so you have a little bit of residual tension so that they don't back off that easily. And from putting some of them in, they are a little bit tight going in. You can put a little bit of air tool oil around the ring, make it go in a little bit better. Make sure that they are snugged up. If you do have a situation where you can't get the die assembly in here, just take the arm, loosen it up, slide it out a little bit, slip the piece up in there. You can bring the arm back in, and then continue putting your piece in. So again, on this piece, make sure that that sets nice and easy. So when we have this set up, we do not actually have to do a pressure setting on this because we're not setting a rivet. We just want to make sure that we have enough pressure to be able to push the rivet out. So I'm just going to bump this up a little bit so it just has enough pressure on it. We're going to go on the back side of the rivet that went through. The smaller little 3mm ones, you'll generally see a little center punch mark in the rivet itself. These are relatively flat right now. So here's a neat little tool that this is a self-centering center punch, and it has two different size hole assemblies here to fit over the head of the rivet to center it up nicely. So in this one we're going to use the bigger one. We just set that on there, drop the pin. This is a case hardened point on here so that when we take that, give that a center punch, and that gives us a point to put our punch into. So when we take this, we're going to start on the punch assembly itself, and that will center up the head assembly when it goes over the hole. If you've noticed this, that we have pressure on this bulges out, that's 1,000 pounds of pressure there that is actually going to help push this die assembly back out so it doesn't get stuck. Rivet is pushed out. This is the actual rivet coming out. And on the outer part of the rivet, you can actually see where that piece of aluminum that went inside actually pushed the rivet back out to lock it into place. So again, on this, center over the assembly. When the piece is up in the head assembly, the next one will push it out or it'll just fall out on its own. A couple of the manufacturers will allow you to reuse the hole on this. Now this is very important. Refer to your procedure repair sheets on what your manufacturer says to do. When you're in the classes of learning on the riveting, on the specific OEs, they'll tell you what you can use, reuse, or not use. So on the GM case, we can actually reform this, repunch the hole, and then set a rivet in there. So what we're going to do is take out our extraction tool. Now on aluminum, if you go to hammer and dolly that out to flatten it out, what's going to happen is you're going to actually work harden the aluminum right around the hole assembly and it will crack. If you actually press it in a hydraulic press, you can actually reform the aluminum back flat again and it will do no harm to the system of what you're working on. So we take these die assemblies here. This is basically going to be the piece that's going to flatten out the material. This is the piece that's going to be on the other end of it for the flattening part. There is a hole in this. This is also what we're going to use to punch a 6mm hole. When this piece goes over top and flattens out the other one, reforms the aluminum needs someplace to go, and it's going to go into this little bit of the hole assembly. So when we reform what we're working on, we are going to be reforming the piece that's actually left on the car, which in this case would be this backside here. This piece, for all intents and purposes, is your outer quarter panel. This will be coming off. We're going to leave this on for our reforming process so that we can use this as a sacrificial panel so that when this piece is over, whatever gets deformed on this side is going to be taken off the car. The piece that's going to be left on here will be nice and flat. So we put our little flattening piece in here, our other piece on the top, and if we do run into the issue of the die being too big to put in, just release the C-arm and just slide it off a little bit so that you can get it set up into the gun assembly, bring it back on in, and then continue putting the piece on. So, very plainly on this, this is the piece that's going to be replaced. This is the piece that's going to stay on the car. So I want this piece to be reformed. In this piece, there is a little center point in there that you can put the opening of the hole over and run this up. And that actually takes us that piece and makes it flat again. Very simple process, very quickly, but it does it with no harm to the material. The other side, you will see just a little bit of push out going into this whole assembly. That's allowing all the material to be pushed around. So once again, we push through on the back side. You do not have to hold the trigger down all the way to let it cycle through. Your air pressure setting, once you do your first one, if it feels nice and smooth, you're good on it. If it feels like it's still sticking through, you can increase pressure a little bit as necessary. And that's how we reform the hole. And then at that point, depending on the size rivet that you're using, if we're able to punch a 6mm hole back in there for a 6mm replacement flow form rivet without any distortion left around it, you can reuse the hole assembly. If you need to do a bigger hole push out on it, an 8mm hole, again, refer to your repair procedure sheet on what to do with that. So in order to punch the hole on this, all we have to do on this assembly is pull off the little flattening head. And in here we have a set of cutting rings. These are 6mm cutting rings. These will cut on both sides of the ring and they are reusable. And these will just go right onto the head assembly. And then we can take this and push through. Punch a hole in the existing material. Again, refer to in your classes if you're allowed to reuse that hole or if you need to punch a new one. These rings will go through an existing hole or no hole at all, and we can just punch one right into the panel. So a nice clean hole. The purpose of the cutting ring, if we look at these dies here, this is actually the 6mm cutting ring built into the die assembly. This is one that would take a cutting ring that goes on top of it. What they've done to make the punching process so much easier is that the 6mm opening up here tapers down to approximately 5mm down here. So when the cutting part goes through the material, it doesn't get hung up in trying to retract back from it. And if you notice that the head assembly will actually pull off, stay up in the punch hole assembly, and the next one that you push through will just push the cutting ring back out. The cutting rings are reusable. You do have openings on both sides with the rings falling out. When you're punching out with cutting rings, take a piece of masking tape, wrap it around these two side holes, punch out about 6, 8, 10 rivets. Go ahead, pull the tape off, and then all your cutting rings are left in here. You're not dropping them all over the floor trying to find them. Pick them up, put them back, and reuse them again. All right, so now we have holes punched in here. We're going to set some flow form rivets. So a couple different types based upon the manufacturer. These are flow form rivets. A couple different types here. So different than the self-piercing rivet, the flow form rivet cannot punch its own hole as it goes through. A hole needs to be set up for the rivet, and what we just punched in here, that's a specific size designed for the rivet to go through this hole. If you notice, this rivet does not fit 100%. There is some clearance around the sides of it. And that's engineered into the size of the hole punch so that when this rivet gets compressed this way, it's also expanding out laterally against the outer part of the panel. So that is engineered in there. They really prefer that you punch the hole instead of drilling the hole, because drilling a hole, you get the wobble of the drill bit and you will not get a perfectly centered hole in there. So some of the differences of the rivets is if you just see the height difference on these, that depends on how thick the sheet stack is. So that's why it's very specific that you have the right size rivet, which is where your repair procedure sheet will tell you to put what rivet in what position. On these two particular kinds, these are GM rivets. This is a 6mm flow form rivet, a standard type of flow form, and then they actually have a countersunk flow form, so that when this rivet is set, it will be flush against the panel. So this is a standard flow form rivet set with the head assembly sticking out, the other end crushed over. And this is the countersunk flow form rivet that GM is using on some of their projects around window openings so that there's no protrusion sticking out where the rivet is. And the other side will look just the same as a standard type of rivet. So on setting the rivets, we now go to a different style of rivet heads for the flow form rivets, and these are labeled C1 and C2. So C will match up. Sometimes on the C's, when you get into the bigger 8mm rivets that are out on the market, you will have some C1, C2, C3, C4, and C5. There's always a chart in the box of the rivet heads that will tell you which ones to match up with what. On these particular ones, these are set up for 6mm flow forms. If you notice the difference on these, this one has a hole in the middle of it and the hole on the side. And what that is for, this is always the crushing side of the die assembly that will allow the glue, excess glue when you're riveting and bonding, to go through that hole assembly as a relief. So this is where the actual head of the rivet would be going into. The base of the rivet actually matches the other die assembly that will have it sit nice and centered in that area. So again, when you put these on, doesn't really matter what direction you put them on. You can put them on whatever's convenient for you for riveting the car. Because we are going to a smaller size die assembly again, we do need a spacer that comes in with the kit. This spacer is a little bit shorter than the other one that we used. So this one, with this little piece that slides in and out, once this is all tightened in there, nothing will move in here. Because this does slide in and out, if we try to put that into the piston assembly right now, this isn't long enough to catch the threads. So if I take one of my die heads and install it now, by putting this in, I'm actually going to take that black piece right there and lock that in, so now this can go in as an assembly and have no problem getting screwed in there. So make sure everything's snug, hand tight. Do not tighten these with a wrench. They do put little wrenches in here. The purpose of these are when you go to take them off, if you can't break it loose, then you can just put the wrench on there and break it loose. These are not meant to tighten up the die assembly in there. Remember, there's not a tremendous amount of strength on stretching the threaded area. That's why we don't use wrenches to tighten them. So again, this area here will go back up into the top. Everything's sitting nice and straight. So when we go to set the rivet, obviously, this rivet is definitely way too long on there. So we're going to go on to one that is equivalent for the smaller material. And we're going to take the base part of the rivet, put it in the base part of the head assembly, and let it carry the whole thing up into the crushing head up on top. Go into the die assembly. We let it run out. And then that's the base of the rivet, and that's the head assembly there that just got crushed over. This will become more of a structural rivet. You'll see more of these on frame rails, A pillars, B pillars, anything where they need a lot of structural strength, because of the rivet going all the way through the panel, then getting crushed over on the head gives you the most strength that you can have with it. On setting, punching the holes, setting the flow forms, We have a couple of issues here. We go through a relatively small stack. This is a very good, efficient way of punching holes through. When we go to a thicker stack of material, some of these cars now are running up to almost 10 millimeters of stack. So when we go into trying to punch a hole through a product that is this thick, this becomes not as stable when you get it under that much pressure. If this is just loose just a little bit, this will end up snapping this piece off. So what they've developed for this system, on the push-pull system, let's take these out of the way. We have another type of setup for doing thicker materials. It's a very stable system and it works really well. So it's still kind of the same process with using the cutting rings. But now what we have is we have two types of heads right here. We have a built-in cutting ring on this head, and this will take the cutting rings on it. This head here is capable of doing up to about a 3.6 millimeter stack of product. Once we start getting past that, it becomes more difficult for the cutting ring to get all the way through the product without drawing more material through it. So we switch over to a cutting ring, and this can do up to a 9.6 millimeter, almost 10 millimeter stack of material. So if you notice on the bottom of this, there are no threads going in. So when this actually goes on the piston, this is going to have full contact with the piston, and it's going to give it the most stability of it to operate. So what we're going to do with this is a little locking ring right here. There's a groove in the piston, and there's a groove in the die head. So the die head assembly will just fit right into that. That'll slide right onto that, and that keeps that very nice and smooth onto the piston. And then we have this little black cage here, slides down inside this area, and that just spins around like that. So if you remember when we were in the beginning taking off the little black collar, that is what this is for now. This will go over top, and this will actually hold this whole assembly together. Make this hand tight. Do not use a pair of pliers on it, and do not have it loose, because now that this piece is on, this piece is very, very stable. If this is a little bit loose, this whole piece will move and you will snap it. So we just put the same receiver piece back up on the top for the die assembly to go into. We have our little piece on here, cutting ring on. Now we can go up to a bigger stack of material. So nice, clean, nothing got jammed up in the system of going through. So the nice part about doing this is you have great stability on this. It's a nice, clean way of doing things, and it's the most effective way of punching through. So once we have the hole in there, you can go ahead and put your rivet in. One very important feature on the flow form rivets, you cannot push out flow form rivets like you can on self-piercing. The reason with self-piercing rivets is that when they go through partially on the other side, and there's not enough strength at that point to keep it from being pushed back out. On a flow form rivet, once the rivet goes through and the head gets crushed over, in order to remove these, again, according to the OE sheets, you either drill or grind the head assembly away based on what they have, and then you can push the rest of the rivet out. But if you try to push this out right now, all you're going to do is rip out that whole stack of material. Okay, we're going to go on to blind riveting. And on the system here, we actually have 3 different types of heads here. And very basically, the smaller head for smaller rivets, and as the bigger as it goes up, and then we get on to the big guy here, which is basically a blind rivet head on steroids. So we're going to start off here with the small one first. Again, they go on the same way. Flip the lever up, head assembly on, push the ring back over, lock it into place. This will pivot around. Nice thing about these heads is that these will also pivot into different directions for depending on what type of area you need to get into. So you can get into a very tight area without having to swing the whole gun assembly in and doing that. Basically, blind riveting, no big deal on that. There's no real power setting for the material. As long as you have enough power going, when the mandrel snaps off, that's when the rivet is set. So there's not real concern on what power to set it at, just as long as you have enough power to snap the mandrel. So on the little fittings for the ends, these are specific size openings for the mandrels. So when you go to pick these up, what we want to end up doing is have the rivet fit in there a little bit loose. If you get the exact size that fits the mandrel on there, it's going to create a problem when the jaws come up to grab it, and to release the pin coming out, there's not going to be enough clearance on it for coming out. So on the sizes listed here, a 3.2, a 3.6, a 4.0, we're going to be using a 3.2 and basically a 3.0 mandrel. So that gives us plenty of room so that when this rivet is going to set, it's going to be fine. Now, part of that process, when you put the nose cone assembly in there, this will actually push the jaws back down a little bit more, give it a little bit of space. So normally when you go to put the rivet in, it's going to want to bounce back out. So all you do is set the rivet in the gun head assembly, go onto the area that you want to rivet, push the rivet in, and let the system do its work. So nice and easily, the piece comes out. So if you're running into an issue where a mandrel gets stuck in there, make sure that you're using the correct size nose cone for the rivet that you're using. So as we go on to, we're just going to go up to the next size rivet, and I'm just going to change out from a 3.2 to a 3.6, just a little bit bigger. So next size rivet going in. So rivet set, mandrel comes out. Basically, when we get into these will be your smaller rivets for this. If you try and put a rivet in this head assembly with a mandrel a little bit longer than this, it's going to be a little bit of a problem in this size head. That's when you go up to the next size. This will take care of the longer mandrel on the rivets and also into the 1/4 inch high strength blind rivets that are being used. This system here works very good. The mandrel will go back into the back assembly with a little cover coming off. That will take care of the little pieces on the back. Then this one here is actually one of the strongest ones right now because it has air-powered assist on setting the rivets. This is used on some of the bigger, the huck bombs, the pin and collar rivets, anything that needs a extraordinary amount of strength to set. This is also going to be used on the extraction system on the stud welder for removing rivets that now you have to weld a stud onto the rivet and then extract the rivet assembly. Some of the new rivets on the Audi Q7 are such a high strength steel you're not able to drill them out. They don't want you to drill them because you're going to oblong the hole. No access from behind to push out, so you weld a stud on the end. There's an extractor piece that will go on here that will actually pull the rivet out of the assembly. That is what the majority of the use of this one here is. So blind riveting assembly, very simple. They all go on the same way. They all pivot around. They give you access to wherever you want to go. You just have to know which one to use for the proper size on the product, and you'll be fine with it. All right, we're going to show the nutsert assembly tool. So nutserts are basically these pieces here that will go into the whole assembly, and then they get crushed down so that they lock in. So the biggest problem with doing nutserts is, number one, trying to crush something this big with some of the hand tools out there. The other problem is trying to get it to the correct setting, where it's tight enough so it won't turn and not too tight so that the threads pull out, or it's loose and it spins in the hole. So there's a neat little formula on how to set this up so you get the correct setting every time. So on the nutsert assembly, into the gun, lock it in. Just like the blind rivet heads, this piece does pivot around. So what we want to do on this is our die assembly set here is just different threads for the different size nutserts that we have. And what we're going to do is, just going to start out with this one here, 6 millimeter. So on these die assemblies, they are basically the same size back in here, the same size on the threads of the nose cone. The only thing that changes is the actual assembly itself to go into the different size nutserts. So we pick the thread according to what we have, and what we want to do is, this is going to be the system that is going to pull this back to crush it. So what we're going to do is remove the nose cone from the assembly. Inside here is the piston that's going to pull back. So this is a little retainer ring that we can now take our assembly, little hex head in the back, will fit into a hex head in here. which actually lines up with this little silver knob, and that's how you're going to be able to screw it in or screw it out once you have it connected. Put the retainer nut assembly back on. And again on this is only going to be hand tight. Don't need to crank it down, but that locks that into the piston. Nose cone assembly goes back on. And then that is going to hold the final nose cone for that diameter of what we're working with. So this is adjustable on height up and down, depending how much you need to thread in for this. And what we want to do is be able to have our thread stick through a little bit so that we know that we have full contact of all the threads inside, and then we can adjust this back up so that it bottoms out against that. Just snug that up, and the nose cone is set. So now what we want to figure out is how do we determine how far to crush this. So on all Nutserts, there's a very simple formula. If we measure from, take a little vernier caliper gauge, have the little depth reading on the back. If we can read from the top of the Nutsert back into where the threads start on the inside. On this particular measurement, this was 9 millimeters. It's going to be the same on this one. 9 millimeters from the top of the Nutsert to where the threads start. So that actually gives us 9 millimeters of area to crush the Nutsert together. So there's two items in there that we have to subtract from that we're not going to crush. Number one is going to be the thickness of the flange. So if we actually measure the thickness of the flange, that is actually 2 millimeters. So we're going to take our overall of 9, subtract 2, and we're going to subtract the sheet stack, which is another 2 millimeters. So those are two areas that are not going to crush in that 9 millimeter zone. So if we take 9 minus 2, comes out to 5 millimeters of movement that we want to put on this to have the perfect setting of the Nutsert once it's in the panel. So now we know the number of 5 millimeters. This red knob on the back is a depth indicator or a depth stop. So this runs out, starts out at 0, goes to 5, 10, 15, all the way out. So I'm going to turn this just so that we get this right on 5. So I have my depth stop set for 5 millimeters. Going to make sure that everything is still snug because now the shaft is only going to pull down 5 millimeters and stop. So when we go to our size there, so holding the trigger, that's it. It's only going to travel the 5. We let go. Now we can unscrew with the silver knob. And now we have a perfect setting on the Nutsert every time. So their threads are not pulled out, so they go in nice and easy. There's no spinning on this, so we didn't over pull it and under pull it. So very simple formula, which is actually listed out right in here. So this little diagram on top is showing the same thing that I just went through, where you measure the depth of the thread, subtract the thickness of the flange of the Nutsert, and subtract the thickness of the sheet stack that you're going through. So let's move up to a bigger size. Let's do the real big one. So same, just reversal on taking apart. Looks like a lot of parts, but it's really not that complicated. Take off the little retainer. So shaft assembly, nose cone, match them back up, put them into the kit. Go to the big guy here, same thing. Make sure that's in. Put our spacer back on. And then we'll drop this in. So I measured this one out. This one is actually 11 millimeters overall. Again, minus 2 on the sheet stack. So we are going to be 7 millimeters total crush on that. So what I want to do is make sure I have enough thread sticking through. Bottom that out. Make sure that the Nutsert is bottomed out to that flange, because when that piece pulls down, that 7 millimeters, if you start off 2 millimeters too high, you're only going to have a 5 millimeter pull on the Nutsert itself. So on here, we're going to take our little gauge, going to run that out to 7. So that sets that up. Power setting on this, again, just make sure you have enough power to be able to crush the Nutsert. There is no specified power like setting a rivet, because this has a depth stop on it and it's only going to pull it so much. So as long as you have enough power out on this to crush it, you are fine. We roll that into our big guy. And again, we just unscrew. Perfect setting on the nutsert every time. It's one of the best things that they've made on this. So we're doing nutserts. Then we run into these guys, where now they have just the opposite. So what they have added onto this program now is same piece, just opposite. Instead of a male thread now, it's female. It'll go onto here. Have the nose cone on it, set your measurements on it, set it. Gives you a perfect set every time on this also. So these are available right now in the 5mm machine thread, 5mm screw thread. I believe we have the 6mm machine thread and screw thread also. So as these products keep coming out, the engineer who's designed this gun is very well with us on making products as we need them. So these are now available also. When you're having an issue with the gun where you need to add fluid to it, this you cannot just take the valve off and add fluid to it. It has to be bled out. We have this great little bleeder kit here. And when you get this, take about half the bottle of oil, open up this part here, pour the oil into the container, and now what we're going to do is pump oil through the gun assembly to add oil to it and bleed air out at the same time. So on the side of the gun is a little Allen wrench. We're going to take that out. We're going to keep the gun up. Catch any residual oil coming out. We are going to have it in an upright position. If you're going to clamp it in a vise, it's only going to be in the bottom section down here, and put something protective on the jaw so you don't damage the gun assembly. We're going to flip this lever up to the open position, and we're going to take our little coupling valve here and switch that open also. So on the side piece, this comes in your kit. This we're going to put in. This will come out when we're done, and the plug will go back in. But for right now, this gives us access to this. And then you can just rotate this up so that's facing up. So out of the two pieces here, the black piece will go up into here, push down, over, and lock just like you're putting one of the rivet heads in there. The other piece on this side, little red cap off, and this piece just plugs into that coupling there. So now as we pump oil through, what we're going to watch here is the air coming back out of the system, and we're just going to keep pumping, and you'll see a little bit of residual air still in the system. And all this is doing right now, circulating the oil in the correct way so that all air travels up. And then once this is, you're pumping it and it's still running clear, that's it. The system is now full. The air is bled out. Got one little bubble coming up here. The air is bled out, and now all we're going to do is just reverse the process of what we did of taking this piece here out, pushing down on the little blue washer, pulling out, capping it. We'll take this piece here, take this piece out, and then we're just going to put our little plug here back in. Now when we take this piece here off, it's important that you do not turn the gun sideways. We're going to have a little bit of residual oil coming out. Let that catch that, keep it in that position. And we're going to put our little valve back in, which is right here. Put our little piece back in. Snug that up. And then just wipe off any excess oil on the system. So that takes care of refilling and bleeding at the same time. And part of the cause is when you put heads in and out on this, you do get a little bit of residual oil coming out on it. So eventually you will start running a little bit low, or if somebody ends up taking the head off without retracting it fully, will also take fluid out of the system. And that's how you bleed the system out. Yep. So a couple of specifics that we have here, the Express Die Kit for the GM program. To meet some of their requirements that they have. The majority of riveting is about 85 to 90% overall. It's the same basic principles. It's when you get into the specific rivets of what the engineer wants on the project and how he wants them put in, that's where some of the specifics change just a little bit. So on part of the GM kit, they do have a standard flow form rivet, which looks like just like the one that we have put in before. And then they also make what's called a countersunk flow rivet, so that when this rivet goes in, it is flush with the surface. There's nothing of the head assembly sticking up, and they mainly use that in structural areas around the windshield area, so that when they're putting glass work in, they don't have any obstructions sitting up for the glass to end up hitting. So in order to set the countersunk rivet correctly, that does require another die assembly that actually has a countersunk built into this, so that when you punch, you put your cutting ring on here, and when you punch the hole out on it here, this will actually make the recessed area of the countersunk in the material, so that when you set the rivet into place, it's flush or ready to start with, and then you can crush the rivet over. So in the die assembly kit, we've gone over, shown a couple of these things where you have the reforming head assembly that will go on and actually flatten out the product so that you can punch your new hole in the assembly. This is where it becomes a little bit specific on the different manufacturers on what type of rivet you're taking out of the vehicle and what type of rivet you are putting back in. You are not always replacing the rivet with the exact same rivet that came out. So when the OE says to take this rivet out and put a different type of rivet back in, that's what you need to do. So in the part of the GM kit comes with the cutting rings, the different types of heads for punching out the holes, for doing the countersunk, for setting the flow form heads. This they actually do have a little bit different one for doing the countersunk ones, because on the countersunk ones there is nothing for this to wrap around, so they just have a flat head with a line up in the center to go into the center of the rivet, so when that sets, this whole die assembly can come flush with the panel and set the rivet correctly the way that it's supposed to. That is the GM program. Mercedes has some very similar items also available in the Express kits for Mercedes. These are a couple of the rivet assemblies for the Mercedes program. And if you notice with the Mercedes part number actually on the package, up here, this S3 and this A2, that is actually what is on your chart for Mercedes for what die kits to use for what type of rivet. The S will stand for steel, the A will stand for an aluminum rivet, and the number thereafter is just a number that denotes the length of the rivet. It doesn't actually convert out to anything, but they actually start out at 0, and I believe they go all the way up to around 28 right now. So it's different lengths of the rivet. It says 6 millimeter underneath. Mercedes also uses an 8 millimeter rivet. And just like the other kits too, they have the reforming heads that go into that. They have the capability of going through multiple sheets of material, multiple thicknesses of sheet stack. The cutting ring assemblies, they have the 8 millimeter cutting ring, they have the 6 millimeter cutting ring. It will do all the flow form punching, reforming, and setting of those rivets of that also. So another specific kit that Express makes is on the Tesla program. And again, some of these materials look the same, and then they have some specific die heads for their specific rivets on there. Nice little list here that will actually lay out what material goes where. So for the specific rivets on their repair program, we have the kits for the die assemblies for the Tesla program, and then we're also going to be having available the die kits for the Audi program also. So same thing on that. It's the die assemblies become very specific on the types of rivets, how it holds the rivet, the type that the head is going to form the rivet over, and that is based upon what the engineering firm wants on when you set the rivets on there. Again, everything goes back to the repair procedure sheets. You always go by the manufacturer's instructions. Anything I've said during this video that goes against any of that, ignore that part and go with what the manufacturer says. This is basically an overall riveting class discussion on the express rivet gun, on how the assemblies go together, how the different processes happen. Always refer to your OE sheets for their specific directions. All right, well, that concludes what we've gone over the riveting. Hopefully that will help you out in your training process. Any other questions or comments, hey, please give us a call. The information is on the screen to contact us. Again, this is Mike V from Reliable Automotive Equipment. Thanks, guys. Have a great day.